Hello, and welcome to Section 4, Advanced Visualization. In this section, we're going to look at some more advanced ways to visualize our data. First, we're going to give an introduction to information-dense visualizations, a way of basically showing multiple layers of data and different data within a single plot. Then we're going to look at how to visualize correlation, the similarity or association of different variables. Following that, we're going to show a technique called linear regression to build a simple linear model describing the real-world behavior of our data. Lastly, when we expand our exploration of multiple variables, showing even more types of data, we're going to use a technique called correlation matrix to quickly show the correlation between all the different combinations of variables. Introduction to information-dense visualizations. Data visualization is a huge field. You can see that just by looking at the various Matplotlib examples on their website. Now, some of the key things to take away from this field without becoming an expert in data visualization are: it's a delicate skill, so you have to be careful not to exaggerate. Even though you have so many tools at your disposal, sometimes using less is more. So sometimes using a simpler method, doing a cleaner plot, shows more information in a clearer way than going for the fanciest of all tools. On the other hand, don't underestimate your audience. It's important to show various insights from our graphics, so we shouldn't just assume that the average reader of our document or a person who's going to be looking at our analysis report won't be able to understand the concepts we're describing. Instead, we should try to teach the audience how to read the more advanced graphs, and don't underestimate them. I like to think of visualization as a way of storytelling. So think about what the motivation of your research is and how to basically use these plots to guide the reader forward to understanding the concepts you've discovered during your data analysis. A key person in data visualization theory is Edward Tufte. He's really mastered the field and written multiple textbooks on the matter. And I highly recommend, if you can, to read his book, The Visual Display of Quantitative Information, which is really the prime source that's really combined all of the important concepts here. And one important concept that he in his book describes is called information density. So think of it this way. If we have a pie chart like this one that shows basically the sizes of 4 items, wouldn't it be clearer if we just replace this by 4 numbers? The pie chart uses a lot of color, a lot of shadows, a lot of fancy effects here, and in the end, the information it conveys is just these 4 numbers. So maybe it would have been better to use a table in this case, or maybe just describe the numbers in text. One of the graphics Tufte uses in his book is the Napoleons March graphic created by Charles-Joseph Minard. Basically, the graph shows Napoleon's army losses in the Russian campaign of 1812. This is the graph. It looks quite complex at first sight, but if we break it down, basically the brown area shows the position of Napoleon's army and the size of the army as it advances towards Moscow. And basically, the x-axis shows both the geographic movement and the passage of time. The black color shows the retreat of the army after their loss, and we can see basically many variables in this graph. This is called a multivariate visualization. So we can see the army size, its location over time, and on the small graph at the bottom, we can see the temperature that's related to the army's retreat. So we can see that temperature is getting really, really cold towards the end of the retreat phase. This is an example of an information-dense graphic that shows many different aspects and basically tells a story in and of itself, which makes it in a way a masterpiece of data visualization. So what sort of graphics are we going to be dealing with? Well, we're going to dive into the data sets we've already passed in the previous sections. So in section 2, we've parsed crime data for Chicago, and in section 3, we've parsed the weather data for Chicago. So in this section, we're going to analyze the two datasets in relation to each other to create an information-dense graphic of our own. So let's get started with the Jupyter Notebook. So this is the Jupyter Notebook I've created for this part. I've created it under the name Chicago Crime and Weather, and I've already gone and copied it from the actual folder on GitHub to the My Work folder so that we can make changes here. So in addition to the normal pandas and numpy imports, we're going to add matplotlib.pyplot as PLT, which allows us to use some fancier plotting. And yeah, we can get into it. So as I said, we're going to be reading both datasets again from section 2 and 3, both crime and weather data. And we're going to be looking at the relation between these two factors. How does weather affect crime? Which is also a topic of a movie that I've linked here. Curious. So one thing before we can get started is I've gone through the crime CSV file again, and what actually happens is that the data is so unsorted in it that the part that we've read wasn't all of the 2016 data. So I've gone on and made a bit of an adjustment to our parsing, which I'll explain here. So first of all, we have the paths here, the original raw file that we've downloaded from the internet. And I've created a new path where we'll save the intermediary cleaner data. And essentially what we're doing here is we're reading the whole file, not just the first certain number of lines as in the previous example, but we're going to be using the chunk size and iterator options to Pandas' read CSV function. What these do is they, as the name implies, they read the file in chunks and iterate over them. So within each of these for loop iterations, we get the df variable with the parsed section of the CSV file. And we can then basically process it a bit. What I'm doing here is selecting just the 2016 data and throwing everything else away. And appending these data frames, which are filtered to only include that 1 year, and appending them to a list of chunks. And I've also gone here and added some variables. Experimenting, for example, we can just do the iteration for a few runs, see if everything is okay or not. We can increase or decrease the chunk size. And there's also the low memory option that I've included here. You can actually try all this out depending on your computer. You might have to tweak the options. I managed to get it running with the version that's on GitHub. So once this big iteration is done, we will use the pandas concat function to concat a list of these chunks into a complete crimes dataset or a crimes data frame. And then we're going to sort it, what we wanted to do from the start, and save it to a CSV file. I've also added the compression flag here to compress the file as gzip to not run out of too much space, because GitHub was complaining that my files were too big. So after running this, if we look at the head, here I haven't gone through the whole file because it's a big task, so you should probably do it before you're going for a walk or something. But just to show you what the output looks like, you're just going to have more rows here. And the function then to deserialize the data is here, so we can then just read our gzip file, so specifying again the compression here, and add these options which we've explained already in section 2 to parse the dates and so on, specify the index column. And I've gone in and added another guard here to just select 2016 data in case you're experimenting in the above function. So if we run this now, we should get the gzip file that I've gone and prepared. If you just copy it also from GitHub, you'll have the same data set with around 268,000 crime cases recorded in 2016. Okay, so that's a bit of a patch to the section 2 parsing. And the weather data, which we've covered in the previous section, stays the same. So basically, we can just use the read CSV function, parse them, and again, I've selected just the 2016 data so that we have both data frames be over the same period of time. So that's it for data reading, and we'll continue in the next video.